mention something. I got an email from Jeremy Sutton, who's the site director for Rankin here at Wentzville. And there is a company in Chesterfield who's looking for someone to work for them part-time, to literally build them a website from scratch, maintain a blog for the company, and do some, you have to understand social media also. All right? Now, the pay isn't much. It's $10 an hour, and it's 20 to 30 hours a week, and they'll totally work around schedules. All right? My guess is that after, you go in and meet with them, you probably could even do some stuff from home. Not sure about that. All right? If you're interested, they want you to send your resume immediately out. I'm not telling you where. I want you to send me the resume. All right? In fact, whether you want to apply for that job or not, what I'd like is by Wednesday, and I'm going to give you 10 points for it. So by Wednesday, I'd like each one of you to submit your current copy of your resume. All right? And I'm going to look through them. I'm going to make suggestions. Now, if you don't want to use any of my suggestions, it's your resume. That's not a problem. All right? If you're interested, definitely interested in this job, just email me by the end of class today. All right? And then try to get the resume to me today. Yes?
You say Wednesday. Do you mean tomorrow or do you mean next Wednesday?
Oh, I mean, let's say Thursday. I'll be even a little more screwed up than usual because, not having class on Monday. You're right. So by Thursday. But if you are interested in this, try to get me a resume by the end of the day today. Jeremy sent me this on Friday, so I'd like to jump on this if there is an interest as soon as possible. Again, if no one shows an interest, okay. All right. And I've mentioned this to you before, and again, you can look at this. I have no idea. I still haven't gone through it to see how good it is or it is not. But there is a thing online now that's called myperfectresume.com that will help you. If you give it information, it will help you build a resume. All right? So let's see. And I have one more handout for you. You are eventually going to have to key this one in, all right? I'm just going to go over the working copy of it for right now because it's a two-part problem that's in your book. I'm going to have you do both parts. I'm not trying to overwhelm you with homework, but I have to give you enough, try to give you enough so that when we have a test, you're like, I don't know how to do this. I don't know how to do this. I don't know how to do this. All right. So at least you will have had practice doing whatever this is. So we're going to talk about the handout I just gave you right now, and we're going to go over it for the next half hour or so, and then the rest of the period today will be lab for you, all right? Tomorrow, remember, you have your written test, all right, and you have your written test for Chapter 9. So as always, when you come in here, the first thing I'm going to do is, have a bunch of stuff on the board for like a test review for you. We'll do that first, and we'll take the test. It seems as though it's taken about a half an hour for most people to finish that. Good. After we do that, we'll go over Chapter 10. All right, so I'll be lecturing on Chapter 10, and that'll probably take an hour and a half or so. All right. And after that, then I want to go through one more example, which is going to help you with this one that we're doing right now. Remember that payroll program that I handed out to you, that employee thing last week? I'm going to go back and make some revisions to it so it's more like this one. I just forgot about doing it yesterday, so it wasn't done. This handout that I just gave you is number 6A that's on pages 418 and 419 of your book. So let's first start by looking at the write-up for it. It says, create a program named Taxpayer Demo. That program should declare an array of 10 taxpayer objects. I cut it down to 4 because I didn't feel like typing in 10 employees worth of information, so I just made it 4. All right? The data fields, yeah. In fact, I wish you would. I mean, that's just, it's too much. You're just typing the same type of thing in 10 times, so that's kind of silly. All right, so the data fields for the taxpayer object, so you'll have a class that's called taxpayer. On the handout that I gave you, I keyed it all in and I screwed up. My taxpayer's got a capital P in it, so it doesn't look exactly like what's shown in the book here. See what I'm saying? They say taxpayer minus TAX capital P. All right? And I just didn't change it. I got it to work, and I'm like, I don't want to start making changes now. Also, I don't know what her problem is. She says it'll have a social security number. Use a string, but do not use dashes within the... Who cares? So you can use dashes. I could care less. So one field will be for social security number. One field will be for the gross income, and one field will be for the tax owed. Does that make sense? Those will be your 3 fields that you have in there. All right? Include a property with get and set for the first 2 fields, and a tax owed. The tax owed is read only. And what they put in here is, I believe that if your income is less than $30,000, your tax rate is 15%, and if you make $30,000 or more, your tax rate is 28%. Okay? Maybe those aren't great numbers. Those are the numbers she used, so we'll use those also. All right? But the key thing in here is this. We're working with an array of objects. So that's what this one does, and we have not really done much of that yet. All right? Turning to the next page there, as it says, the tax should be calculated whenever the income is set. Assume that the tax rate is 15% for under 30. 30 or above, it's 28%. Okay? That's what you have in front of you right now. You will be responsible for keying that one in. All right? Rather than you keying it in now, I wish you'd watch as we go through it, because I like it to make sense to you. You've got this here, so you can key that in whenever. All right? But you're going to do on your own Part B. Create a program, so copy your folder when you get it done, the whole thing from Taxpayer Demo to Taxpayer Demo 2. Again, you only need to have 4 objects rather than 10, all right? But sorted in order by the amount of tax owed and displayed again. Modify the taxpayer class so that they are comparable to each other based on tax owed. What does that mean? You're going to have to use that iComparable. And you go, we didn't do that yet. I'm going to go back to the employee example, and I'm going to put that in and give you a hard copy of that, and we'll go over that tomorrow. So you'll have something to base it off of. All right? So, bottom line, what the heck does all that mean? The bottom line is it means that you already have done number 1, all right? So you'll have to do number 1 for your homework, and hopefully everybody did that already and got it done, and you'll have to do number 6. You'll have to, you've got Part A that I've given you, and you'll have to do Part B on your own, all right? In addition, I have not yet looked at the debugging exercises, but I might assign those too, because you really don't have that much to do. You have only 2 problems in here. So I want to do the debug exercises, and if I think you'll get something out of them, I'll let you know that tomorrow. But at a minimum, you'll have to do number 1, that hockey one, which you may have done already, and parts A and B of number 6. All right? So that said, let's take a look at this program, all right, with the taxpayer stuff in it. So I'm going to bring my copy of it up on screen. You've got hard copies that you can take a look at yourselves. All right, first thing, let's run it just so you can see what it looks like. All right, Social Security, and again, I put the dashes in, 111-11-2222. What's their gross income? Well, you want to check, the reason I made it 4 of them, all right, the reason I made it 4 is it says that if you're making less than $30,000, your tax rate should be 15%. So let's make it less than $30,000. That'll be the first one. Then the second one. All right? That one I'll put right at $30,000 because they should be charged 28% for tax. But let's double check. All right? Then for the third one, we'll put somebody who's over 30,000. Again, that should be 28,000. And the fourth one, anything you want. So notice what we have. The first one, 20,000, 15% would be $3,000. That looks correct. The second one, 30,000. That should be 28%. And that's what, 30 times 28 is 8,400. The third one, again, 45 times 28%. All right, I'd have to do the math, but that should be right. Right under 13,000. And the last one, 55 at 30%. So do you understand the inputs and the corresponding output? Do those make sense? You're putting them in an array, which we did not do previously. All right? So I want to go over all of this with you. All right? I've already gone over pretty much have gone over the comments, so I don't think there's anything that we have to say. The tax owed is read-only. You already know how to set that up. All right? So let's look first and notice that for the array, all right, and I didn't have to do this outside, but I did it outside of main, and I've got a constant there that I just called num taxpayers that I set to 4. Then we've got an array here that's called citizens. That's an array of 4 different taxpayer objects. So each citizen will have to put in their social security number and their gross income. And for each of the 4 citizens, we'll figure out the tax that they're owed. Does all that make sense? If this was a real life project, you would have a lot more tax rates than what are shown right here. The author just kept it simple. All right, and we've done the same. But you'll notice if you look in here, again, this is why you use arrays. I don't have to sit there and say, go ahead and set up an object for the first one, then read in this, and then read in this. Set up an object for the second one, read. Third one, read, etc. We're doing everything inside of a loop. All right? So when we come in here, this is creating a new object. Again, I didn't put the comments in, but I'm going to put a couple in here. Instantiate a new taxpayer object. That should make sense. Input current taxpayer objects social security number. That should make sense. Input current taxpayer objects gross income. All right, and again, that should make sense. All right, now we're going to loop through for each taxpayer object, figure out their associated income tax, and print same. All right. Really not a whole lot that's going on in here in main. We're using 2 loops. In the first loop, we're generating all of our inputs. And in the second loop, we're generating and showing all of our outputs. Okay? So let's take a look at the associated class that's here. All right. You'll notice that there are some constants in here. Limit, that's that $30,000 figure. Probably over time that's going to change. That's why it was made a constant. Again, so we only have to set it in one place. The low rate, those are people that are making less than 30,000, they pay 15%. That's 0.15. Everyone making 30,000 and above is going to be taxed at 28%. That's the 0.28. All right. You should all be far enough in your programmatic careers that those lines that are right there make sense to all of you. Okay. Then for our Social Security number, again, notice we're calling calculate tax. I'm sorry, the Social Security number is just to get set. We're not doing anything special there. So again, we can put comments here. Set up property getters and setters. All right. Nothing special for Social Security number. All right. But we are doing something in here. We're calculating the tax. We're calling that right from income. That's why we can't just use the get sets. All right. For the tax, remember that's read only. So there's a get there, but there's not a set. We did not have a value here that we put in uppercase, all right? We didn't do that because we're asking them that. We're figuring out what their tax is based on their income. Their tax is either this or it's this. It's one of those two, and we know that. But unlike the last problem where it was always the same, here it's one of two values. So even though we only have a get here, we didn't have a constant variable that we used above, because we are still inputting that. And it's pretty simple calculation. If the income is less than $30,000, you take that income and you multiply it by 15%. Otherwise, you take that income and you multiply it by 28%. And notice we're setting tax to that. Everybody see that? We're not passing it in. We're setting tax. So that tax that's right there is this tax. It's right here. Remember one more time? These are called what? They're instance variables. So for each instance that we're creating, each person is going to have a Social Security number, they're going to have an income, they're going to have a tax. Really, I probably should have done this. I like to put my constants in first. Again, you may or may not agree with that. Now, I'm asking you this. Take a quick look through what's on the handout I gave you. All right? And I don't care if you look, which one you look at first. We can start with main. All right? Again, we are creating an array of 4 taxpayer objects. Our loop control variable, did we have to do that here? No, we didn't have to. All right? And the entry string, remember, anything that we read in is automatically a string. Okay? And here we want to convert it to a double. This one we don't even need to use that for, but we only have 2 things. We've got a gross income, all right? And that gross income, that's this. Okay? But we're doing that in here, and that's why we've got these fields. So again, just like we looked at before, we mentioned before, here's where we're eliciting the inputs from the user. Here's where we're printing out the associated values, either what they gave us or what we calculated. So take a quick look at everything that's in the main part of the program there in the handout that I gave you. And let me know if you have any questions. Yes.
So for the instance variables and instance constants, those are like, they're not global, but they're class global?
They are global inside of the class. These are global all over because they're public. So anyone could use those. Even another class that would interface with this one could use them. These are private, which means that the only way that we can tinker with those is through the associated public methods. And again, I've said this to you before, I'm just gonna say it one more time. With literally, I'm not gonna do this right now because I don't wanna confuse you, but literally, if I spent a period on this, I could show you in one class period how to take everything that's in this chapter and convert it to Java. Because there's very few changes you have to make. And the good news about that is when we go over this kind of stuff in the Java, a year from now, it should be more review than anything else. You know, in the Java class, they have a whole chapter on if statements and switch. You already know those. They've got a whole chapter on for loops and while loops and do while loops. You already know those. So when we get to that, it's going to be a lot of reviews. So I plan on when we get to that stuff, we're just going to breeze our way through it. All right, if you've looked at that, then go over to the taxpayer class and take a look at everything that's in there and see if you have any questions on anything that's in there.
How do you make something read-only?
Technically, the way that you make it read-only, the question was how do you make something read-only is you provide a get routine, but no set routine. If you wanted, you almost never see this, but if you reverse that and you made something with a set and no get, it would be write only. It's very rare, if ever, that you're going to see that, but just so you know. All right?
You still have to put read only as the variable.
No, because the tax is something that we are actually calculating. All right? But once you've calculated it, again, you know, that's Brady just asked a really good question here. All right, if you look up on the screen, again, when you look at this, let's assume for just a second that, all right, so we're putting in here for an income, $44,000. And we know that if a person makes over 30, that they get charged 28%, right? So I'm gonna multiply that by 0.28. So that person gets charged that amount. Everybody agree with that? I shouldn't be able to change that now. Would you agree with that? That's your tax rate. All right? That's why there's just a get there. All right? It actually is being set in here. All right? But in the routine itself, all right, the getters and setters, there is no set. So once it's set down here, you can't change it.
That's right with the read only. Got it.
All right?
Makes sense.
And again, most of this stuff is explained, and the author goes through sometimes painstaking detail to talk about this stuff. All right? One more thing that I wanted to mention to you, because we didn't really spend very much time on it, but I want to go back to the end of your chapter. I just wanted to show you something. So let's suppose it's a couple days from now and you've got it, you're at home and you're working on the homework and you're like, man, I know you went over this in class, but I'm just really totally confused as to what the heck we were supposed to get out of this, what this was, etc. All right? On page 398 in the book, the author talks about how you can use sort and binary search with arrays of objects. For part B, the part you're going to have to do on this one, you have to go and sort this based on, I think it was the tax. So you're going to want to take a look at the explanation that's on 398, all right, and the example that's given at the end of the chapter. Again, I'm going to give you something similar tomorrow, and I'll give you a hard copy of that. Going along with that, if you'd all look up on the screen here, because I just kind of glazed over this. But this is something we're going to talk more about in Chapter 10. And that is when something is abstract. If you look on the bottom of the page here, they talk about an abstract method. All right? A class can be abstract. All right? So, if I came in here tomorrow and I was all fat and happy and you all said, wow, you know, you look happy, what's going on? And I said, I just bought a new pet. What would a natural question be?
What'd you get?
What kind of pet? Because that's really pretty generic, right?
Yeah.
And then I said, I got a dog. Well then, what kind of dog? See what I'm saying? So when you make something abstract, you've got to kind of look at this, that when you go and you're starting to, if you work for a company and they say, we want to take everything that we do at this company and we want to set it up, and we basically want to set it up in what's called a hierarchy of classes. The higher up you go in the hierarchy, the more general your classes are going to be. The lower you go, the more specific the classes are going to be. So I might say, for example, I might have here mammal. And underneath mammal, I might have pet. And underneath pet, I might have dog and cat and pig. And under dog, I might have, for example, I don't know, terrier type of an idea. So you can see here, I'm going from very general to very specific. That's the way you set these things up. All right? And I took a class with a guy, and maybe I told you about this, that he worked for a company that handles thermostatic controls. They were going to totally object-oriented in their company. Nothing they had was object-oriented. They were changing languages. They were changing everything. They had just 2 whole departments working on this for 2 years, and it was going to be, they're working on it full-time. There were somewhere around 100 people. He told me that their level, this is called basically it's a class hierarchy. Their class hierarchy was 500 layers deep. So imagine that as you go down. It's kind of like when you're writing an outline. This would be a Roman numeral, then this would be a letter, and these would be numbers. You know how you're going again from being very general to very specific. The reason I'm telling you this is this class right here and this class, these two, in fact, all of these would be considered abstract classes. What does that mean? If a class is abstract, you never create an instance of it. I don't create an instance of a mammal. That's too generic. I don't create an instance of a pet. That's too generic. And you might say, well, what else would you have under here? Well, for example, maybe I would have like whale. I don't think anybody has a whale for a pet. What was that goofy movie that was out a few years ago when the kid had a whale for a pet? But you get the idea, all right? You have a bring your pet to school day, you're not going to bring a whale with you, okay? But classes like this would be set up and they would be abstract. When something is abstract, you can't create an instance of it. So I could not create an instance of mammal, I could not create an instance of pet, or even dog or cat or pig, because they're too general in nature. That's what you do when you abstract things. You know, and what I could do here is I could say, for example, let's just say, for example, all mammals, for whatever reason, you know, we say all of them have a name. So I create something like name. Then when I say all pets, I don't know, have a birth date. Now what happens is, what we'll get to in the next chapter when we start talking about inheritance, that means that since mammals have names, all pets have names, all dogs have names, all terriers have names. All right, because they end up inheriting this stuff. And if I say, since all pets have birth dates, all dogs automatically have birth dates, all terriers automatically have birth dates. So what you do is, you're going from general to specific. Anything that's up here, that every one of these has to have, you can define it up here. All right? But you can still change it here if you want to or need to. We talked about that last week. We talked about the speak method. And I mentioned I could define a speak method up here for pet. And I'd have a different speak for dog versus for cat versus for pig. That's what we're going to get into in the next chapter. All right? So it says you can have abstract classes, you can have abstract methods. All right, we'll get into abstract classes more in the next chapter. But it says an abstract method has nothing inside of it. All right, you may or may not remember this, but a term I gave you earlier this semester we've looked at was API, Application Program Interface. And I mentioned that an API is kind of like a contract between you and the software, where the software says, I'm going to provide this stuff for you. But if you want to use it, you've got to agree to use it in the way that it's meant to be used. All right? Well, as it says in there, in the next chapter, we'll learn more about abstract methods. For now, understand that it says, understand that an interface is a data type like a class. In the next chapter, we're going to talk about interfaces. We've talked a little bit about overloading, but in the next chapter, we're going to talk more about overriding. And again, the good news is you're going to get this again a year from now. By that time, hopefully, it'll all be reviewed. All right, so again, last time I want to make sure everybody gets this, and that is, what is it, 406. That I want everybody in here, you all must turn in this test hockey player, okay? And that's number one. I gave you the code for number 3 so you can look at it. You don't have to key it in. You don't have to do a flipping thing with it, but you've got that. All right, I just gave you the hard copy for number 6A. I want you to key that in. Again, you can make this 4 taxpayer objects. If you want to keep it 10, you can. It just seems like a lot of overkill to me. But you have to do part B on your own. Tomorrow, I'm going to go back and try to fix the employee object thing so that it has arrays, and I do this, so you can see how it's done. I'll give you a hard copy of that one. All right, in between today and tomorrow, I'm going to look at the debug exercises at the end of the chapter. If I feel you'll get something out of them, you're gonna be have to do those as well. All right, and last thing then again, tomorrow, what that means is tomorrow, written test, first part of class, chapter 9. All right, then I'm going to lecture on chapter 10. After we've lectured on chapter 10, I'm going to give you an example program. All right. The only other thing, I was thinking about this the other day that I forgot to do, and it's the first time in 9 chapters. So if you want this, and that is, let me get rid of this. Is what we've done is we've gone over those, what is it? No, not solutions. Structural materials. No, that's not that either. No, where the heck is it? The review questions that are at the end of the chapter. There they are. So if you want these were all at the end of the chapter. So I don't know what page this is on your book, but it's right at the end of the chapter. 402? 414. Okay. So number 1, an object is what? An object is an instantiation of a class, also known as an instance of a class. I can guarantee that virtually every one of these questions in some form or other will be on your test. All All right, so number 1 is C, instantiation, also known as instance. Number 2, a class header or class definition can contain all of the following except initial field values. So the header or definition can have the optional modifier public, private, protected, has the word class in it because it's a class header, and it has an identifier, the name of the class. So number 2 is D. Number 3, most fields in a class are created private. If they're not private, you'll see in the next chapter, then they're almost always going to be protected. But that's not important for right now. All right? Just remember that they're private. Number 4, most methods are public. And I already told you that most of the time you use public methods to manipulate private data. That's the hallmark of object-oriented programming. So number 5, instance methods that belong to individual objects are never static. To say they're never static means they are non-static. I don't remember which way they put it on the test. Okay. Number 6, to allocate memory, when you create a new object, you use the new operator. So number 6 is C, new. Number 7, assume you've created a class named myClass. The header of the myClass constructor can be, you can't use, let's see, neither of these can be the constructor header. Why? Well, this one right here, you can't have a return type with a constructor. That's why that's illegal. It's called myClass, so you can't say myClass constructor, so these are both illegal. What you could say would be just public myClass, all right? Number 8, assume that you have created a class named myClass. The header can be, and it could be either one of those. Remember, you can overload, all right, the constructor. So the first one would be a no-arg constructor. The second one would be a one-arg constructor. So either one of those would be potentially legal. So number 8 is C, either one. Number 9. Wow. Assume you've created a class named demo car. Within main, you instantiate a car object, and you want to do this. Within the car class, the compute method can be, there's no question like that on the test, but the answer is B, public and non-static. So number 9 is public and non-static, B. Number 10, assume you created a class called term paper that contains a character field called letter grade. You also created a property for the field. Which of the following cannot be true? The property name cannot be exactly the same. All right. You saw how we've been changing in there is the caseness. So we would make this letter grade with a capital L for the property name. All right. The property could be read-only. We just learned how to do that. The property could have a set accessor that didn't allow a grade lower than C. And the property, it's possible, might not contain a get. It typically won't happen, but it could. Number 11, this reference is A. That's on the test. Implicit and passed to non-static methods. So non-static, implicit. Number 12, when you use an instance variable within a class's non-static methods, you can explicitly refer to the methods this reference. So you can use the this dot. So 12 is B. 13, a class's default constructors sets numeric fields to 0, and it has no parameters. So both of those are true. Not only does it set numeric fields to 0, it sets Boolean to false, it sets strings to the empty string. All right. Oh, so 13 is C. 14, assume you've created a class named chair with a constructor that takes in an integer. Which of the following overloaded constructors could coexist without ambiguity? Well, the first one would be illegal. Remember, just because the names are different, it's int and it's int. The second one would be okay because it's 2 ints where the first one only had 1 int. So that is B is a valid way of overloading. Number 15. Which of these correctly instantiates a house object if it contains a single constructor with an int or a double? Single constructor with an int double. It says 2 of these. Well, it would be these 2. Int double, int double. That one would not be legal because we've said it only has one constructor that expects an int and a double. So B and C, I think that's funny that she put 2 of these. I guess sometimes as an author you get lazy. Number 16, you explicitly call a destructor. You never do. So 16 is D. You cannot call a destructor. The destructor is called automatically by the system when your program goes, your object goes what's called out of scope. All right. So 16 is D. You cannot explicitly call a destructor. Number 17. In a program that creates 5 object instances, the constructor executes 5 times and the destructor executes 5 times. But remember, if I create 5 objects, so I do number 1, then 2, then 3, then 4, then 5, that's the constructor. The destructor does it in reverse order. So that's the destructor. All right. Number 18. Suppose you declare a class named furniture that contains a string field named wood type and a conventionally named property with a get accessor. When you declare an array of 200 of these, which of the following accesses the last furniture's wood type? All right, so it's the name of it, which is my chairs. So the first one is definitely out. All right. It is a field. It's not a property. That's why this one would be illegal. And this one to say dot wood type 999, that's just illegal. My chairs is what the array is. So it's got to be my chairs bracket something. That's why it could only be B or D, and it's not a method, it's a property, which is why D is the correct answer there. Number 19, a collection of methods. This is going to be, we'll look at this more in the next chapter, that can be used by any class as long as it provides a definition to override the collection's do nothing or abstract definition is called an interface. So 19 is D, interface. And the last one, number 20, let's get that up on its own page. When you create a class and want to include the capability to compare its objects so they can use array.sort or array.binary search, you must write a compare to method for the class. Again, that's one of the things you're going to be doing in your assignment. Anyone need any of those repeated? All right, then the last hour and 50 minutes or hour and 55 minutes or 2 hours, whatever it is yours.